Okay. So you guys can see the screen with the PowerPoint, correct?
Yep.
Okay. So this is, we'll get started. Oh, Jeff, can you put yourself on mute for a second? Thank you. I just hear you typing. Okay. Anyways, so this is the 3P04 workshop. So today what we're hoping to cover is a bit and help you review a bit of the hardware and software skills to help you with your design projects. So there's 4 of us that'll be here. So I'm Amanda. I'm in my 4th year of electrical and biomedical engineering. And then Sandia, she can do her little intro.
Hey, I'm Sandia. I'm also in my 4th year of electrical and biomedical.
And then we have Jeff.
So hello, my name's Jeff. I'm in my 4th year of biomed and mechatronics.
And
hey
Conrad.
guys, I'm the one who's been annoying you through the posts. My name is Conrad, if you don't know, and I'm in my 4th year of HESI.
Yeah. So we've all taken this course before. So what we're going to do is Sandy and I are going to work and kind of walk you through a bit more of the hardware aspect of the course, getting your circuit set up, and then Jeff and Conrad are going to walk you through a bit more of the Arduino IDE, writing your code in the Arduino IDE, and kind of a bit of the background language in C and such that you would need. Okay, so we will get started. Give me a second. Okay, so this is an overview. So we'll kind of just go back and do a bit of a hardware basics review. Sensor basics, so what sensors you guys are using in the pins, and then a little bit about the setups of attaching them to your ESP32. We'll then also go and do the software review. Like I said, we'll touch a little bit on the C language and the syntax for it, a basic coding review, and then we'll do some examples of the coding in the Arduino environment. Okay,
So we'll just start with the very basics of some electrical components. So on the left, we have some resistors. So the one on the top would be a 3-band resistor. And on the bottom, we have a 4-band resistor. So essentially, the way you would read this, the last color is always the tolerance value. So that basically represents the error in your resistance measurement. And then the rest would follow this chart. So let's say we were trying to find a 100 kilo ohm resistor. The first value would be 1, so it would be brown. And then we would have 0, so it would be black. And then the third value in this case is going to be your multiplier value. So it would be times 10 to the 4, so you would have yellow. And that would be a 100K resistor for a 3-band resistor. And then the same principle applies for the other ones. And then in the middle here, we just have some LEDs, which are diodes. And on the right, we just have a basic button.
so most of those you should have seen before and had some experience with in your kits. You probably also have your wires here. So there are different types of wires, and the names are kind of pretty obvious once you think about it. So you have like male to male wires, which have the 2 little prongs sticking out. You have male to female wires, and then you have female to female wires. And basically just allows you to attach different components to your circuit. And they can attach different ways to your Arduino, depending if you want to use your breadboard or just attach it directly to your Arduino. So those are some of the basic ones that you guys might have seen and you're probably using, but just so we have their naming right and we kind of all are on the same page with that.
Okay, so here we have the 2 basic ways that you can connect components in your circuit. So on the left, we have 3 resistors connected in parallel. So if you look at either end of all 3 of these resistors, each end is connected to the same point or node in the circuit. So essentially, the resistors will all have the same voltage across the component. And then on the right, we have a series connection. So all 3 resistors will have the same current flowing through it rather than having the same voltage across. And we'll show you how to actually implement this on your breadboard in a bit.
So looking at the diodes or the LEDs, this is probably the next most common component you see beside your sensor. So you'll have your LED here, and I believe the ones that you guys are using have the long end and the short end stick or tips, and the long end is the side on which the positive current the positive voltages, and then the shorter one goes on the negative voltage. Or an easier way to think of it is the shorter one is going to go towards ground, and in between your positive lead and your positive part of your battery, or your microcontroller, you're going to have a resistor, and this basically just allows and ensures that there's not too much voltage here, and so that you basically won't burn out your LED and such. So in terms of the circuit diagram, if you guys have seen these, then basically the direction of this line here shows you the direction of the flow. So basically the arrow is going to be the flow, the way that the current flows. So you can say that in this case here, this here, it's going to be your negative, and this is going to be your positive. So the current always flows from positive to negative. So in this case, our voltage is going to flow this way. So we would want to attach this to the positive lead of our circuit, and then to the ground or the negative end of our battery to actually get our light to turn on.
Okay, so here we'll just go over how connections work in the breadboard. So the breadboard essentially allows you to connect your components in a non-permanent way, as opposed to soldering them together. So if we look at the edges here, the 4 rails on either side are all connected together. So it would go from one end to the midpoint, and then the midpoint to the other end. And those would be 2 separate connections. And then in the middle of the breadboard, each of the columns, so as Amanda has drawn there in that black line, one column, all of those holes are connected together. But each separate column is not connected to each other. So essentially, when you're plugging things into your breadboard, if you want 2 wires to be at the same point in the circuit, you'll need to plug them into the same column for them to actually be electrically connected.
Oops, we went the wrong way. Okay, so here's an example of, pretend these are horrible, even though those are horrible drawn wires, they actually look like wires once they're bent the wrong ways. But this would be like an example of the 2 wires being in series, because this one starts at like one point, and then it comes to this middle column here. And from the middle column, the second wire then goes to the next column. So because these wires attach at a common middle point, we would say that they're in series. So that is different than the example on the right here, where we have 2 wires both starting at the same column or the starting node, and then they go to different points. So this here would be analogous to when you have them branching off going in different directions. So series, they always are going to have a middle common node, whereas parallel, they're going to start at the same node and then go in different directions or different locations on the breadboard. So if you can see, Jeff has a small little setup there about showing the difference between the series and the parallel. So I'm trying to see. So the green is going to be our parallel, our series. So he has the green going to the middle node, and then it's connecting out. And then if you hold it up a little higher, the red ones are going to be the ones that are in parallel, because they both start at the same node and go to the same node. So in parallel, they don't have to go to the same node, but they will start at the same node. Okay, so that's just a basic review of stuff that you guys probably would have seen in 1E03, but it's been a while, so we wanted to make sure that everybody was on the same page with that. Okay, so I'm not 100% sure what sensors you guys are going to be using, but we'll cover 2 of the basic sensors and kind of talk a little bit about how you set them up and get data from them and what the important parts are of each. So in this one here, this is a sensor we used last year, and this was like the BN005, the orientation sensor. So looking at it here, there's a bunch of like holes and pins on the bottom, but there's only really a couple that you are really going to need to actually do data measurements with. So the first ones would be your SCL and SDA. And then I2C is kind of similar, and it kind of falls in a similar path. But you can get away with SCL and SDA. And basically, what these do is these allow for a serial clock. And basically, this just allows for you to time how fast you want your data to be transmitted. And then you have the SDA, which is actually how the data is transmitted between the sensor and the Arduino. And so you need to have these two. And then like other sensors similar to this, you're going to have a ground and a V in. So your sensor, in order to work, actually needs power. So you need to make sure that your ground and V in are also supplied. And that will allow you to it to work. So if you don't have a power supply, it won't be able to calculate things. So you have to make sure that those are done. So in total, to get your sensor to work, you'll have 4 connections.
So the other sensor that you guys might need is the pressure sensor. And it's also called a force sensitive resistor. So unlike the other sensor that Amanda talked about, you don't need any SCL or data pins for this one. And this sensor is essentially a resistive component. And when you apply force or press on it, the inside wires will touch, and that'll complete the circuit so that current actually flows through. And you can use any GPIO pin, but you will need a pull-down resistor, which I'll explain later.
Okay, so those are just generals about how they work. We will, once it goes. So this is your ESP32. So this is the microcontrollers that we were using. So on this, there is several pins, and it looks very intimidating. So we kind of wanted just to highlight some of the main pins that you will need to know, especially if you're using the orientation sensor. So in every case, you have 2 ground pins, and you're going to use these to connect your sensor to the ground of the microcontroller, and then also it needs to be grounded itself. You then have a 3-volt and a 5-volt beside your 2 grounds. These are important for supplying either your different components with voltages so that they can function. Your orientation sensor will use the 3-volt. If you use 5-volt, that'll be too high, and it could potentially burn it out. So you want to make sure you're using the correct voltage. If you're using too low of a voltage, that could also prevent you from getting proper readings of your device. So make sure when you read and look at your data that you're using the correct values. In terms of the actual pins, so to actually attach your SDA and SCL pins, you want to use pin 21 and 22. So these have been explicitly outlined in the microcontroller to allow for you to do these functions. And these ones, you have to use these pins for these locations. However, there's several other GPIO pins that can be used, and they can be used for input and output. But once you get to writing your code, it has to be specified what it's actually being used for. And you can't really see it, but at the bottom of the link here, or the slide, there is a link, and this is like a reference manual. And so I can pull it up, I think. So this is kind of ugly, but if you're unsure of how to use your device, then your reference manual, there's a technical reference manual, and there is a data sheet. The data sheet's probably what you're looking for more. The data sheet will basically kind of give you a rundown of everything your device does and kind of help you locate what pins do what. So if you're unsure if you need a certain type of input or output, or like a converter or something like that, you can check the data sheet for all of your components, and it'll tell you how it operates and what voltages it'll operate at and such. So those are a very good resource to check. You can also just Google like the file, and it will allow you to find it. Maybe a bit quicker than reading through the data sheet. Okay. Anyways, so, oops, going the wrong way here. Okay, so here is a sample setup of how you would set up the orientation sensor with your Arduino. So in this case here, you would want to attach your 3-volt pin to your V in, and then your ground to the ground pin here. And then you also need to make sure that you're attaching your SCL and SDA pins to the correct pins. So on your breadboard, or if you're using, I believe it would be, depending on how your sensors are here, if you're directing it directly to the breadboard, you can put it on the pin. Otherwise, you can put it in like the column that it's attached to. And you basically want to attach the SDA to pin 21 and the SCL to pin 22. And that will allow you to create a communication line between your orientation sensor and your microcontroller, which will allow you to collect the data and determine the speed at which you're actually going to be taking those measurements at.
Okay, so before we go on, does anyone have any questions? I think someone had their hand raised earlier.
Yeah, I had a quick question. Can you go to the last slide? So like I saw that there's a 3v3 on like on the really top over there. Sorry, on the general on the sensor. Is that a 3v3? Like
Yes.
on top of the vent, like is that for power as well?
I believe you can use either of them. If one of you guys want to correct me, this one here I believe is for like 3 volts explicitly, and that would be like a 3-volt power supply. But I believe you can also use V in.
Okay. And when you mentioned that there's a V, is there a VM pin on the sorry, I still don't know what it's called. ESP32 as well.
I don't believe, I don't see one. There potentially could be. You'd have to look at the numbers and see. But what you would do with that is that would come from an external source. So that would not be, you would not attach V in to the V in of your microcontroller, because your microcontroller has its own voltage source that it's supplying to your sensor. And the V in that's on your microcontroller would be a location where you would put the voltage supplied to your sensor. So you wouldn't use VN and BN. You would use either the 3-volt or the 5-volt. But in this case, the 5-volt could burn out your sensor, so you don't want to use that one. You want to use the 3.
Okay, I see. Thank you.
You're welcome. Okay. Is there any other questions? Okay. Let's go to the pressure sensor.
Okay, so when you look up the data sheet for this pressure sensor or FSR, this is basically the circuit that you're going to find. So you'll have to set up this exact circuit to get your sensor to work. So essentially, there's 2 pins that come out of the pressure sensor, and one of these pins is going to be connected to your power supply or the 5-volt pin. So you can see that's the red wire on the picture on the left. So that connects to the 5 volts. And then the other pin of your sensor is going to be connected to ground, but it will need to go through what's known as a pull-down resistor, which is your 10 kilo ohm resistor here on the diagram on the right. So essentially what the pull-down resistor does is, if your circuit is not connected, so there's no pressure being applied on the FSR, and it's essentially an open circuit there, it'll ensure that the voltage reading at that point is not some random floating value, and it's pulled down to ground, so it'll read as 0 volts. And then if pressure is applied to your sensor, then you'll get an actual proper voltage reading. So it's essential that you do have a resistor connected there, or else it won't function properly. And then at the midpoint there between the sensor and the 10 kilo ohm resistor, that's where you plug in your GPIO pin and get a voltage reading. And that's the blue wire on the diagram in the left.
Yeah, so that would be this pin here, and then this would be your ground and your voltage. And then, as we said, this here is an analog voltage, which basically means that it would want to be converted to a digital. So you'd have to make sure that it's going to a digital pin, so that way there can be converted and interpreted with your microcontroller. So if you want to explain this, Sandy.
Yeah, so here is essentially what the setup that I showed on the previous slide would look like. So we have the red wire coming from one of the pins of the sensor, and that's going to the 5-volt power supply pin. And then you have your pull-down resistor connected, and that's connected from one of the pins to ground. And then also from that same pin on your sensor, you're going to have another wire, and that's going to be your analog voltage reading. So you'll need to connect that to one of the pins. So here we have pin 34, And within your actual Arduino code, you're going to have to initialize this pin as an input pin.
Okay. So those are the two main sensors that our groups worked with. I do believe there were other sensors that potentially could be available to you guys, but the setup is very similar. Usually, especially if there's one like the orientation sensor, where it has multiple inputs, you're going to have either an SDA or something like that. And if you look on your data sheet, you'll be able to see which pins correspond with the names, whether it's like I2C or something like that, that's on your microcontroller, and you can connect it to the direct pins through that. So there is like a map on your microcontroller. I had a map up earlier, but it was the wrong microcontroller, and I figured it might confuse you, so I took it off. But if you Google like the microcontroller you're using and then just say pin map, you should be able to see the list of all the types of pins. A lot of them are GPIO, meaning that they can be used for input and output, but there are specific pins, such as pin 22 and 21, that have specific functions, such as the SDA and SCL, so that you can use those sensors with that. So certain locations have specific things, but most of them are general GPIO. So I just double check with the actual one that you have, and then you'd be able to see where specific ones are. Okay, so we wanted to also just show you guys a sample setup of how you would do an LED. We kind of walked through this a little bit already, but here we're going to use just the general input pin at 2. And basically how it works is you're going to have your current come through 2, and it's going to go through the positive lead of your diode, and then it's going to go through your diode and back to ground, and then that's going to allow for the diode to light up. So in this case here, when we run our LED from our microcontroller to the LED, we have to make sure that we pull or we put that resistor there. Similarly to what we said before, we want to make sure that the value here is not going to be, the voltage isn't going to be too high, and we get the proper current. So we put in this resistor here. It's like usually 10K, and that allows us to get the proper current and voltage for our diode to operate properly. So there's usually only 2 pins, and then once we have it set up in the Arduino IDE, we're going to initialize this pin as an output pin. Okay, so another thing that you guys may be using in your circuits is buttons. So buttons are an easy way to kind of get data, turn on and off something, and so on and so forth. And they're they can be kind of confusing at first, but they're not too difficult to get set up. So in this case here, we're going to have our pin initialized at 4. And basically on one of the legs, you're going to have your positive current, and that's going to, or your positive voltage, and that's usually the 5 volts. And then on your other pin in parallel, you're going to have it connected to ground through a pull down resistor. And then we're also going to have it connected to our pin here. And basically then what happens is we're going to have, when this button gets pressed, then that allows for the current to flow through here. And then that allows us to get a value read at 4. So in this case here, there's 3 connections that you need in order to get your button to operate. So if you were to have this set in a breadboard, then you would have 1 pin going from your 5 volts to the same leg or same column as your leg, the one leg, and then the other leg, you'd have 2 different connections coming out of that column. You'd have one going to ground and then one going to the 4 pin or whatever pin that you have designated. So those are basically the main kind of setups that you would be using in terms of your actual hardware and getting it set up. I think that's all we have for that. Yes. Is there any questions on the hardware side of things?
Do you prefer to use a breadboard or create like, which one is like, which way is better? Using a breadboard or just directly connecting them?
Probably using a breadboard. In the case of how I have it here, I only have it like this because I couldn't, like, I was just easier to draw it this way than kind of fidget and put the breadboard together. But especially until you're certain on your circuit, a breadboard is easier because it allows you to move your components around very easily and kind of move connections. And you can still kind of, even with the orientation sensor or the pressure sensor, you can still do the tests with it, and it kind of just allows it to be in a compact little area. Once you guys actually get to building your prototype, the breadboard itself is quite big. So you'd probably want to connect the pieces physically together, whether that be through soldering or there's like little connector pieces you can get. But I'm not sure like what your requirements are for the design project this year. But in general, getting set up, the breadboard is probably your best and easiest go-to to start.
That makes sense. Thank you.
You're welcome. Is there any other questions before we jump to Conrad and Jeff? Okay. If there's no questions, then we will jump to Conrad and Jeff, and I'll let them share their screen. They're going to be walking through a bit more about the software side. So working in C and kind of working with the IDE in the Arduino IDE. So they're going to take you through that. So you stop sharing my screen so you can take it. You're good. Okay.
And that's
take
here.
it away.
Okay,
You're good.
Cool. So yeah, this is kind of the software part of all this. This is less about actually showing you how to code and more how to kind of think through some of the more common issues you're going to see. So at the end of the day, anything you want to do in Arduino has already been done. Don't worry about like, oh, I don't know how to do it. Google it. Someone has already done it. This is such an established platform. It's going to be out there. So that's the first thing. Use Google. It's going to save you a lot of time. So I'm going to hit on a few major features of the IDE before we actually get into the code. So what you can see up here is this verify button. What this does is it looks through all your code and it says, is this going to work? Then we have next this compile button, or sorry, upload is what they call it. But essentially, this is the, okay, put this all together, send it to my board. Then you have some other stuff relating to files and saving and stuff like that. It doesn't really matter. What we really care about is going to be this tools tab. There's a lot of really good stuff in this tab that we need to make sure we hit. The first one is what's called serial monitor. So it doesn't work because I only have 2 USB ports, but the serial monitor is essentially a way to send information back and forth from your Arduino. This is going to be really helpful for debugging later on. Other important features, we have the board, so you can select your appropriate board, and then this port option will become ungrayed, and you'll be able to select your COM port. So these are sort of the main 2 things you need to verify before you can upload to your board, which we're going to do in a second. And then otherwise, we also have auto format, which can be really helpful for just quickly cleaning up your code. And the only thing I'm going to get everybody to do, and this is going to make your life infinitely easier, file, preferences, you're going to check enable code folding and display line numbers. What these do is it adds all these numbers along the side, which are going to make it really easy when your partner's like, what about this on this line? And this gives them a number to give you rather than trying to fish for it and figure out what it is. And code folding is going to be really important later on, but essentially it lets us turn things like this function into a single line. And that makes it really easy to control how much code you are visually dealing with at one time. So those are kind of the most important things in terms of your options, your verify, compile, upload. Any questions about any of that before I actually plug in an Arduino and I start showing you basic things, and then we'll get into the code.
Ooh, you should show them how to do their port and find what port their thing would be on.
Yes, I'm going to do that in a second. I just want to make sure that there's no questions about any of that little bit that I showed. So if we're all good, okay. So when it comes to your Arduino, you're going to see a handful of things. So the first thing you need to do is you need to check the appropriate board. Now, for me, it's going to be an Arduino Uno. For you guys, I don't think they have, I think you're just supposed to use the regular Arduino Uno as well. But you can verify that. That should be in the instructions that you were given about the project and the boards. So USB, plug it into the socket. This is going to depend on how many devices you have available at one time. So you may have more than one device here, but for the most part, most of you are going to have a single board, and it's going to appear, and yours is going to say COM0. It's not going to say dev TTY, unless you're on Mac maybe. But this is a Linux thing. But essentially, you're going to have like COM0, Arduino Uno. Select that, make sure it's checked. So now you've essentially said, this is what I'm going to send all my info to, right? It's going to be this board, and I'm going to send it over this channel, COM port 1. So now you are good. You can send whatever you want to your Arduino. A really good way to make sure you have your Arduino set up correctly is in File. They have what are called examples. So these are actually really, really helpful for doing a whole bunch of different stuff. But the best one, and the one I find most useful when I'm having issues with my Arduino, is going to be examples, basics, blink. So this is a pre-done sketch. You have to do absolutely nothing with it. Essentially, all it's going to do is see this orange LED. It's going to flick it on and off every second. So tools, make sure your board is correct, make sure your port is correct, and then you just click upload. So you can see down in this bottom corner, I get it before it was saying uploading, and then it says done uploading. And now if we look at my built-in LED, we can see that that is flashing on and off, and it wasn't doing that before. So this means that I have successfully flashed this blink sketch. The term for a file in Arduino is a sketch. So a blink sketch has now been flashed to my Arduino, and that light is going to blink. So that is a really good way to test to make sure that you can upload your code correctly. So now when we go back to our 3P04 workshop, I'm going to re-upload my 3P04 code. And now we can see I've re-uploaded that 3P04 code, and it's no longer blinking. So that covers flashing a very, very basic sketch, a pre-done one, to ensure that your board and port are set up correctly. So we will hop back. Any questions, any comments, anything like that before I get into the outline of what an Arduino sketch is and what we can do inside of it. The reason I'm asking a lot of this, like, are we okay with this, is because this ramps up very quickly. A lot of the concepts that I'm going to talk about build on each other. So if you are confused, something's not 100%, take the time to ask, because it's only going to get worse. But yeah, okay, cool. So let's talk Arduino. So Arduino in general is a platform, and specifically this is an Arduino microcontroller. So a microcontroller, I remember you guys used Raspberry Pi, that is actually a full single board computer. The main difference between a single board computer and a microcontroller is that a microcontroller runs repeatedly. It does one thing, and it does it really, really well, and it does it over and over and over again. Let's say you had a program where you needed to go online, you needed to search something, you needed to browse the web, you need to do all these different things. That's when you want to use something like a Raspberry Pi. It's a single board computer. It can do anything a regular computer can do, and it's great for that. This thing right here is not that. This is really good if you are running a blast furnace, and your blast furnace needs to be at 1380 degrees Kelvin at all times. And you need to measure those changes and see if it changes, we need to add more of this, or we need to trip an alarm. That thing that the sensor goes into to constantly measure over and over and over again is a microcontroller of some type. Probably not an Arduino, probably something a little higher end, but that's what this is used for, is repeated measurements of things. And anything that's repeated measurements of things is going to be likely some variant of a microcontroller. So satellites, braking systems in your car, temperature monitoring, you name it, it probably runs on a microcontroller. So it's all about, they run all the time, they check all the time. In Arduino, there's two functions that make it unique, and you have to have these for it to work. The first one is the setup function. Is there another way to test other than the LED? The kit we got doesn't have an LED. You can flash any number of other basic programs. Like the other go-to one that you can do is just do like a loop, which we'll talk about in a second, and you can do like serial.println, and you can do a hello here. Close that, add that, and you could also do like a void setup, serial.begin 9600. So if you really wanted like a really simple function to test if it's working correctly, you could flash this. I'm going to get into what this means later, but when I talked about the void and setup functions, so setup is a function that runs a single time. It does one round of whatever's inside of it. The loop function is going to go over and do the same thing over and over and again. In this case, it's going to print hello infinitely. So this actually is probably too fast. You probably want to do what's called a delay. So delay is time in milliseconds you want to stop. So remember sleep in Python, delay is the same thing in Arduino. So in this case, we are going to say set the baud to 9600. The term, yeah, I didn't realize, didn't initialize an orange LED. Yeah, so that's built on. Like this one has, that's like actually the built-in LED on this thing. I don't know if ESPs have them offhand, but Blink should work for that. If that doesn't work and you need to test it, void setup serial.begin. So baud 9600. Your serial port baud is going to be 9600. What does that mean? The term baud refers to the speed at which you are communicating. So when I'm talking to you, my words come at a set time, baud 9600. My words come at a set time, baud 11:15:200, right? So you can set different numbers, and I can showcase those numbers in the serial monitor. So it's not going to like this because I have this code here. But essentially, you can see down here that this 9600 baud, right? These are all the different bauds. My advice for what you're doing, run 9600. Things run slower, things run more consistently, makes life just a little bit easier. So yeah, when it comes to your baud, pick whatever number you have your serial.begin as, whatever this number is, make sure you have the same thing selected in the serial port. And that's going to let you talk. And so you have 9600 here, 9600 in the serial monitor, and then you're going to print hello, wait a second, hello, wait a second, hello, wait a second. So let's actually do this. Well, I'll actually flash that for everybody. Oh, no, it's not going to like this. It's the problem with only having 2 USB ports. So I will do this. I will comment all this, and then I will uncomment this, and we can actually flash this and showcase. So this is a really simple Arduino sketch. So you'll see when we crack the serial monitor, hello, 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 hello. So this is a really simple sketch to test that can also make sure things work if you don't have the built-in LED. This was using the setup function. So we set our baud in the first one, and then we are going to print the line, hello, and then we're going to wait 1 second, and then we're going to do it over again. Super simple Arduino sketch that we've done. So let's take a second, unpack that, and go to questions for that, because I know that was a lot of info, but that's another way to test, and that's a very basic way to test, and a very basic thing that you can flash to see if everything is working as expected. So yes, let's take questions. Is everyone following? Is this too much info? A little bit of feedback, just so I can kind of gauge where everyone is feeling before I get into the technicalities of like C code. But this is an example of a very, very simple Arduino function here. Okay, I'm gonna assume everyone is okay. How do you initialize the orange LED? So that's actually going to be in the blink function itself. So in this case, you're going to set your pin mode to LED built in, which is an already set type. And then you're going to do this. So if you actually just go to your examples built in, it's going to pull up this same blink code. And you can have a look at how they do it. But they call this LED right here, which is called LED built-in, which is probably some number. I don't know what it is off the top of my head, to be totally honest. LED, if it is on the, yeah, so depending on your board, it's either pin 13 or pin 6. And LED built-in is just another way to say pin 13 in this case. And this just smartly assigns it because it knows what type of board you're working with.
Thank you.
Cool. Any other questions? I know it's a lot of info dump, so I want to make sure people are okay before I do the next round of info dump. Okay, cool. So yeah, that covers everything up here. So we are here, part 1, typing. Okay, so when you are programming, things have to represent. So if I say an apple is an apple, it could be a red apple, it could be a yellow apple, it could be a green apple, but it's an apple. You could essentially say that every apple is of type apple. And so when we talk about a language being typed, in this case, Arduino, which is a dialect of C and C++, is a statically typed language. What does this mean? If I am going to assign something apple, I have to say it is of type apple. In Python, you don't have to do this. In Python, if you assign a green apple, it knows it's an apple. So when we look at this, we see int a equals 1. Unpacking the statement, we are going to first look at int. Int refers to integer, right? So it's not a floating point number. There's no decimal. It's just full, complete numbers. Integer. What are we going to call this integer? We're going to call it a. And what are we going to assign to this integer? We're going to assign it 1. So that is an assignment statement in Arduino. You need the type, you need the name, and then you can optionally initialize and assign. So the difference when you hear people talk about assignment and initialization, int b is an initialization. We are going to create this variable b, but there's nothing assigned to it. It's just null. We don't know what it is. Here, when we do b equals 10, this is an assignment. We are going to assign 10 to b. So that's the difference between an initialization, int b, and an assignment, b equals 10. And you can do it in the same line. So when we look here, char character y equals c. So we are saying that this variable y, which is of type character, is equivalent to the letter c. So here, Isa was asking, if we define our variables in the loop section of our code, does it take more time due to the IDE having to assign the variable every time it repeats? Yes, it is going to take longer. Is it going to matter in actuality? Probably not, but you probably don't want to be assigning your variables in the code. And I'll kind of talk about why in a little bit. So these are just basic assignments here. So this is the difference between assignment and initialization. And in Arduino, something interesting to note, if you ever see the word double and the word float, they mean the same thing. It's essentially just a number with a decimal in it. So let's look at some big problems you're actually going to see. These are real things you're going to see because everyone does these. The first one, b equals 1. We verify our code and we see that b does not name a type. So we didn't say int b, we just said b, right? Rather than saying type apple, green apple, we said green apple, right? So when we put int here, int b, it's going to play nice. It doesn't like this because I have this assigned up here. So let's put this as like D. And so when we do this, B does not name a type. Interesting. No, oh well. Anyways. So we can see that when we put int there, it's fixed. Next up, we have int test equals 10. So this statement is going to freak out. Expected a colon or semicolon before void. What does this mean? This means that somewhere before here we have missed a semicolon, and when it comes to C, C++, Arduino, you gotta have semicolons at the end because it tells them where the line ends. What comment shortcut do you use? Control / is the shortcut for commenting. If you want to know other shortcuts, you can open up edit and it'll give you a bunch right here. And also stuff like auto format. They all kind of have their shortcuts listed on the right. And then the final one, this is interesting. This is a technicality when it comes to C and Arduino. You're going to get this. An error occurred while uploading. Oh, no, it doesn't like that. Wrong thing. Oh, is it going to let that through? Really? There we go. That's more like it. Verify. So kind of interesting. Normally this freaks out a little bit more. So I wonder if it's because I'm on a different compiler. But depending on your compiler, it won't like this, and for good reason. So this right here, double quotes doesn't actually create a character. The difference between double quotes and single quotes is important in C++ and Arduino. So think of single quotes as a single character, double quotes as more than one character. So this should actually be freaking out right now, but it's because I'm on Linux and not Windows. Essentially, we are saying a character Z is equal to a string of characters C. So normally, you'll sometimes run into errors with this. So this is an example of an error that would be uncaught. Actually, I imagine I can probably do this if I do compiler warnings all. Okay. Yeah, here we go. So if you don't have your compiler warnings on, it might freak out. But essentially, we can see const char pointer to char. So we'll get into what this means, but essentially, if you want to assign a single letter, single quotes, more than a single letter, double quotes. But yeah, that's just kind of establishing that. So any other questions about that? And what I did for those compiler warnings was file, preferences, compiler warnings, all. You can also do default or whatever, doesn't really matter. So if we are all good, cool. Yeah, so now we're just going to get into functions. Functions, pretty easy, not the worst thing in the world, going to be really valuable for keeping your code clean. So once again, they allow you to repeatedly do an action without writing all the code for it. Your inputs are known as arguments or parameters, and your outputs are your return values. So the basic outline is you have your return type, which is going to be different than Python. Remember, in Python, it was just def, name, arguments, and you could return return int, right? So whatever type you put at the beginning has to match what you are returning. Oh, did my internet cut?
Yeah, I think.
Okay, I thought, sorry, did my call drop there?
Yes.
Okay.
After you said return.
Not a big deal. Okay, I'm back. Yeah, so essentially what you need is you need to specify the type. So whatever it was, remember int char, right? whatever you are going to send back, so if I'm going to send back a 1, it's going to be of type int. So whatever you are going to return, then it's the name of your function, and then it's going to be in the parentheses your arguments, and then within the squirrely braces, it's going to be your actual function. So when we look at this, right, what is going on with my thing? Okay, so when we look at this, we see void. What does void mean? It means nothing. I'm not going to send anything back. I'm not going to turn anything in. You need to have a void at the beginning. You actually don't need to have a void here. The void here is optional. You can just do empty braces. But for this our basic function, we have nothing that we're going to send back. We're going to call it our basic function. We have nothing we're going to send in, and then we're going to print the line our basic function. When we go down a little bit more, let's look at the sum function. So we have a return type of int. So we're going to send a number back, and then we're going to call this whole thing sum, and then we're going to give one number that is going to be called x, and one number that's going to be called y. And then in here, we're going to create a variable called result, and then we're going to assign result to x plus y, and then we're going to return result. So notice how the int of result matches the int for the return type. So that's kind of what we're talking about when we say that you have to specify the return type for your function, and you have to return the correct thing. Any questions about this so far? Cool. Okay, now scoping. So we talked about the basic function outline. This is an important concept to understand because you may waste a lot of time on this. When looking at functions, they are a box. The things inside the box and the things outside the box affect each other in different ways. Things that are defined outside this box can be accessed inside the box, and things that are inside the box cannot be accessed outside the box. So a really good example is when I compile this. Int scope E, unused variable, we don't really care about this. This is not important because it's just saying that this isn't used. But when I uncomment this, right? So we have int scope E here and int scope E here, but it doesn't freak out, right? The reason being is that in this function, scope E it's only in this function. It's only in this void that int scope E equals 1 exists. This int scope E exists outside of this function. So if we actually move it to above this, so remember here, it doesn't freak out. It works just fine. And then when we put this above and we compile, oh, interesting, it doesn't freak out. I would expect it to. Anyways, but if we define another one inside this box, for example, oh no, I see why. Here we go. So when you define 2 in the same thing, it freaks out. When you define 2 outside in the same scope, it freaks out. But when you define 1 in the scope and 1 out of the scope, it doesn't freak out. That's just it yelling at me about compiling. Yeah. Okay. Go away. So do we see how this works? So to explain it one more time, everything inside scoping example exists only within scoping example. Everything outside scoping example exists outside scoping example. Things outside defined above can be accessed inside, but you can also overwrite them. So this would be really bad practice because even though I said it's equal to 2 out here, when I call int scope E inside, it's actually going to be equal to 1. So it's really important to check the scoping of your variables and to make sure you have unique names. the reason I'm spending so much time on this thing that seems really weird is because people can waste a lot of time by not understanding the scoping. So if you have questions about the scoping, this is a really good time to ask them.
I guess just to like make sure we understand, like two things in the same scope, not okay. But one in outside, one in inside is okay.
Yes, so the reason this yells at me is because it says scope E has already been declared, right? And this is also going to yell at me because it's going to see the scope E here and the scope E here, and it's going to freak out. And it's going to say scope E has already been declared, redefinition of int scope E. But it won't yell at me because this scope E is at a different level than this one, but you can still access this one. This int scope E equals 2, you would actually be able to access that inside scoping example. But this error is uncaught because this scope E will take precedence. So even though everywhere else in this code scope E is going to be 2, inside this particular function, scope E is going to be 1. Because we have reinitialized a variable that is going to overwrite this one. So that's a really kind of interesting uncaught thing, because I would expect them to catch that. But yeah, so that is function scoping. Yeah, so this is talking about the examples. Another thing, variables are deleted. So I remember I had someone ask earlier, what if we define variables in our loop? The problem is that loop calls itself over and over and over again. So your variables, those, depending on whether it calls a separate function with the variables initialized inside, might get reassigned. So for example, in this subtraction here, it's always going to be 1000 minus x, because every single time we call subtraction, that variable result is always set to 1000. Down here, we have one where it's going to be 1000 minus x, the previous minus x, the previous minus x, because we have this term static. So what the term static means is that anytime you call this function, the first time through, result is going to be 1000, but the next time through, result is going to be whatever it was last time. So if I put in 2 here, the first time through it's going to be 1000, right? 1000 minus 2 is equal to 998. The second time through, it's going to be not this, because this has already happened. It's going to be 998 minus 2, 996, so on and so forth. So that's the thing. When you call a function without the static, all the variables are reinitialized every time. So this would always be 1000 minus 2. The other way to get around it is to use a global variable. So you could have subtraction result outside the scope in the global scope, because remember I said up here, right, I would expect in scope E2 to throw an error, but it doesn't, because inside your functions you can access global variables. So in this case, subtraction result is 1000, and then we're going to return subtraction result minus x. Actually, it should technically be subtract result equals subtract result minus x, and then you return that. So essentially every time 1000 minus 2, 998, return 998. 998 minus 2, 996, return 996. And you'll notice it should not freak out. Oh, see what I meant by everyone forgets semicolons? That. Okay, questions about function scoping and function variable creation and deletion. Cool. Okay. We're on to an actual part where we'll do some stuff, and then we'll take major questions, and then I'm just going to walk through some code just to keep it pretty brief. So let's talk this one. So serial.begin 996, baud is 996. We're going to create this int sum value, and then we're going to call our basic function. So remember, that was this print statement right here. And then we're going to sum 1 plus 2, and then we're going to print the value, and then we're going to print this is the end of setup. This is only going to happen one time. Then we are going to go lower down in a different scope, right? Int static sum val equals 0. Sum val equals sum of summation value and 1. Then we're going to print that summation value. Then we're going to print loop again, and we're going to check if it exceeds 100. We're going to say exceeded 100, and then we're going to delay a little bit, and then we'll exit. And so I'll talk about why some of this is done the way it's done. But essentially, plug this in. So serial tool, serial monitor. So we'll flash our script, serial monitor, and boom. Okay. So if you ever need to reset a function on your Arduino or your ESP, there's a little button. Tap your little button, and that's going to reset it, and you can get it to run again. So let's go all the way back. So we have, let me just put this in like a side by side. So we can see that we set our baud, and then we initialize and assign our value for 0. We call our basic function, which prints our basic function. Then we are going to calculate the sum, right? 1 plus 2, 3, and we print it. And then we print this is the end of setup. So we can see how this function right here, right? All the stuff in setup only happens one time. We don't see this more than once, we only see it once. Now we go down to the loop. Sum value equals 0. So initialize and assign. And we're going to add 1, and then we're going to print the number. We're going to say loop again, and if it's greater than 100, we are going to say exceeded 100, and then we do a slight delay, and then we exit. So we can see we have it looping, 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 and we see it hits 101, and then it's going to print loop again, but actually it exceeded 100, so we exit. Questions about this? To explain the reason why this delay 100 exists. Oh no, it doesn't like this. And you may need to include this in your code as well if you have a set stop point, is because it will sometimes trigger the exit while it's communicating to the serial monitor. So when we look at this and we save this and refresh this, we can see that validate here, serial monitor. Here we go. And boom, you'll see that actually it says loop again, but it doesn't print everything. The reason being is that it's sending data, sending data, sending data, exit, and then it just stops. It doesn't get to finish sending its information. So you may need to add that whenever you have an exit condition. It's just a small delay to get rid of any lines you previously had printing. Cool.
Great question.
Comments, concerns? Oh, yeah.
I was wondering if you don't have like the exceed and in your serial monitor.
Yeah, what's your question, Lily?
Oh, sorry. Can you hear me? Can you hear me? Hello?
Yeah.
Okay, sorry.
Mhm.
So if you were,
Yep.
if you want to pause the serial monitor at some point, but like you're kind of continuing repeating and like taking the value, can you do that without the exit? Like if you just want
Yeah.
to pause at some point to show your place to your friends to make sure that.
So Yeah, so I've done that right here. So we're going to see this. This is just going to keep printing. It's going to print forever. But what's happening right now is I have this auto scroll button checked. So when I click that auto scroll button, you'll see my little knob here keeps going, right? Because there's more and more values being printed. But I'm at a static spot, so I can go back and I can scroll and I can do these other things. And if I want to catch back up, I can just click auto scroll again and I'm back there. So yeah, auto scroll will do that. Also, if you don't want to show timestamps, just click that button and don't show them. It can be helpful if you have things that might be sending data at different times and maybe you have one triggering at the wrong time, but it's up to you.
I see. Thank you.
So yeah, that's how you can do that. Cool. So any other questions? Because essentially that ends the demo portion. So if people have to dip, people have to dip. The next part is I'm literally going to walk through the code I wrote for 3P04 and tell you why I did things the way I did. And people can ask questions about how that works. So for those of you that have to go, thank you so much for coming out and thank you for listening. Hopefully this was kind of helpful. But otherwise, it's just kind of a casual conversation now about why I wrote my code the way I wrote it and kind of answering general questions people may have. When I was reading online, some pins are referred to as A0, whereas some pins are referred to as numbers. I wonder if you know exactly what a pin is called in the Arduino IDE. Okay, so all pins are numbers, but the terms A0, D whatever, these are all colloquial ways of referring to them. So when you actually look at your board, let's see if I can get this in frame. It's going to be pretty dark. Can I get it away? No. Okay, well, here, do this. This is going to be hard to see. But if you look on your board, you're going to see a bunch of white writing. Right, you see all that white writing? That's going to tell you what these various pins are. So A0, when you look at the Arduino, it's really, really hard to show. Can I rotate that? Okay. Nice. No, I don't think I'm going to be able to. Oh, wait, I'm on the wrong side. Can I like get the light? Oh well, doesn't matter. Either way, A0 in this case represents your analog pins, which are right here in this bottom corner. So you can use those as reference. So you can use like A0, A1, A2 as your analog pins. I don't know what they're going to be on digital. I think they're purely just the actual numbers themselves. And it's going to be different on ESP, but that's what it's referring to. So when you see A0 and whatnot, that's all your analog pins.
I see. So like to figure out which pin exactly you have to go. A0, ESP32, pin number. Sorry, I feel like I have a strong.
Yeah, so you pick what pins you want. In this case, what I... No. Like, I'll kind of explain it, how I did it. So usually you want to pick set pins that you're going to use all the time. And these set pins are nice because you just set it up and then you can use it everywhere. So in this case, I picked pins 19, 22, 21, 35, 34, and 37. These were the pins I picked on my ESP. I can't remember which ones off the top of my head are analog and digital. But there should be a pinout diagram, like a diagram they give you with all the pinouts. You should be able to pick from there, and you can either name those directly, or you can use something like a A0. But I don't know if that's going to work. Int test equals A0. Probably not. But yeah, when they refer to that, I think depending on your board and stuff, it might already know what pins those are. But I guess talking about this is a really important thing for any of you is the name you assign to your pin number. Yes. So yeah, A0 is the name you would assign if you want. Or you can do what I do and call it like red pin, green pin, blue pin, toe pin, heel pin, EMG pin, right? This was easier for me than using A0 and stuff because I didn't know what they actually were when I was working on the board. So I find this more helpful. It is the name it by the function it's going to perform. You guys probably also need to include this, which is the Bluetooth library. So for those of you that want to use Bluetooth. And personally, I prefer global variables for everything I do, especially in Arduino. It's really clean. It's really easy. So you can see here, I set up a whole bunch of pin modes for all my different pins, and then I put all my LEDs low. So this means I don't want them showing any colors, right? So that's a really simple setup function. And then you can see I've created this display green, display red, display blue. So the reason why this is done this way is because I wanted certain ones to display certain ways. So it's really easy. Remember when I showed you that code folding thing? This makes it really, really easy to look at, right? Because I can just hide this. Because I've written this, I know what it does, I can hide it. This was all about creating an output so that I could send data over the Bluetooth and make it easily parsable. So we can see the structure for a for loop here. So int I equals 0, I less than a number, I plus plus. So every time what it's going to do is it's going to take this I and it's going to increment it. So kind of like for I in range length of an array in Python. This is the same sort of thing, but this is the C syntax for it. Important to note, semicolons between each of these statements, not commas, semicolons. And then we can see an example of the dot length function. So if you need the length of an array, that's an easy way to do it. Let's see what else here is kind of important. Analog read. So Arduino uses digital read, digital write, analog read, analog write. So depending what pins you use, you have to call the appropriate built-in function. So in this case, because these were all analog pins on the ESP, I had to analog read all of these pins. I don't think I have a digital read here, but you can see here are some digital writes for writing to the different LEDs. So there's certain built-in functions that you may need to research, but the big ones, digital read, digital write, analog write. And otherwise, some if statements for parsing things, because I wanted to send things from Python to the Arduino code. So that's all that was. But yes, what I would say to people is use the commenting feature, right? Because look at how compact and nice this is. And if I'm having an issue in one specific spot, I can just expand it and look. It makes the whole thing a lot more visually manageable. Do global variables, save yourself the hassle, don't do statics, just global variables. Const, oh yeah, I forgot to mention this. Const means it can't change. So my array length is always going to be 3, so I can never change it from 3. This is just a good habit to get into, especially if you don't want to accidentally change something. The more you can constrain things, the less likely you're going to have random errors. But otherwise, I think that's it. I think everyone else has had it out. So, yeah.
Okay.
Any other questions, Lily?
Yeah. Sorry, can you explain what the I++ thing was that you were showing? Like you're saying that it's different syntax from.
Yeah, so in C, so in C you can do like a variable, if I can spell, variable equals a number, right? You can also do variable plus plus. So what does this mean? This means that you're going to add 1. Plus plus means add 1. You can also do variable plus plus equals a number, and this is going to add the number to the variable. And the same thing works for subtraction and multiplication and all this other stuff. But essentially plus plus means add 1. Minus minus is take away 1. It's just kind of the short form for doing that.
I see. Thank you.
Okay, so if there's no other parts, then if there's any other questions, I think there's just Lily and Carrie left. So if you guys have any other questions, we can answer them. Otherwise, we probably won't stay on much longer because there's only you guys left.
Thank you so much for this workshop. It's actually so helpful.
That's good. Carrie, did you have any other questions?
I have a quick personal question about setting up because I'm using a Mac.
Okay.
And so I don't have a COM port, but I do have the dev TTY.
Okay.
What happens when I plug in the ESP is that there are two that pop up, and I'm not too sure if I'm using the right one. There's one that's the driver that I don't know. We were asked to download, and then there was another one that says USB serial with some number at the end.
I would think you probably want to do the serial. I think. You might be able to check on your, like, I know in Windows, if you go to like device manager, you can see, like, I don't know if Mac has something similar where you can see the actual ports and the comms related to it, but you'd be able to then to go see which actually comm it is on, or whichever like line yours is and whatever it's called. What you could do is try testing it in like how Jeff said, where you do like the serial.print and that kind of thing, because then you'll be able to tell if you have the right one. You should be able to see on the serial monitor like it printing.
Okay,
So you should
I'll
be
try
able
that.
to see. Yeah, try that, because then you should be able to see
Honestly,
the port or the data.
yeah, just try flashing blink to it. Like, try one, and if you flash blink and it works, that's probably the right one. Because I remember I had something similar with the ESP because it's kind of stupid. But yeah, so try that. Just try flashing blink, see which one works. One of them it's going to work, and the other one's going to freak out.
Okay, thank you.
Sorry, I have a quick follow-up question. Sorry, I promise it's the last question. When you have, okay, so like when you have like serial dot print, is serial the library name? Like what's that dot representing? So like for example,
So
as you have
serial is the serial object. Yeah, so the serial object is inherently declared in Arduino. So here, for example, when you look at my code, you can see ESPBT. So I create a class called ESPBT, and I use it further down in the loop function. And you can see that I check to see if it's available. So essentially, serial is already built in. It's an instance of the serial class object, and so you can just call it with its different methods. So serial.begin sets the mode, serial.print prints, whatever